Welcome to this tutorial on cost volume profit analysis. Cost volume profit analysis, or CVP in short, looks at the effects of differing levels of activity on the financial results of a business by examining the relationship between sales volume and profit. If you're running a business, you always want to reach the break-even point as quickly as possible, because after the break-even point, then you start making profits. So basically, the break-even point is the point at which you have recovered your costs, but you've not made any profit at all. So any sales after the break-even point will take you into profits. This study is mostly about formulas. You do well to memorize the formulas. Most of these formulas, if not all, are not given in the exams. So as you start the tutorial, you want to jot them down, stick them somewhere where you can revisit them at short notice, maybe on a daily basis, so that they stick with you. So the first formula that we're going to look at is for a single product break-even analysis, which is the break-even point, which is given as fixed costs divided by unit contribution. You should know contribution. Contribution is simply sales minus variable costs. The ratio of contribution to sales is an alternative method of finding the break-even point. It gives the amount of contribution earned per dollar of sales. It can be measured as a fraction or as a percentage. At times, it's also known as a profit volume ratio, or the PV ratio, and it can be used to determine break-even revenue. So another formula that we need to memorize is the contribution sales ratio. Again, this formula is the contribution sales ratio. You'll find it even in other studies. They'll expect you as brought forward knowledge from this paper into other papers. So you need to remember the contribution sales ratio, which is given as contribution per unit divided by selling price per unit, which we can use to compute the break-even revenue. If you substitute that in the formula, fixed cost divided by CS ratio will give you the break-even revenue. You could also compute the break-even revenue by multiplying the break-even point times the selling price. Then we have another formula, the margin of safety, which is a measure of the amount by which sales must fall before we start making a loss. As you should know by now, that a loss is made if sales volume is less than break-even point. So businesses may want to give discounts to stimulate sales, but for the managers to be able to give these discounts, they need to know the margin of safety, because by giving discounts, their sales will drop, but you want to give a discount to the point that you do not make a loss. So we use the margin of safety, which is given by the formula budgeted sales minus break-even sales. We could also compute this as a percentage which will be given as budgeted sales minus break-even sales divided by budgeted sales. This approach is used to find an expression for the break-even sales volume. It can also be extended to find the volumes needed to attain a required profit level. So you may have a target profit figure that you want to attain. So you want to know the volumes that you need to sell for you to get this profit. So the required profit is like an additional fixed cost which must be covered before the company breaks even. It is given by the formula: output required for target profit equals fixed cost plus target profit, the whole of that divided by the unit contribution. We now apply these formulas in an example question. So we have this example question. A company has fixed costs of $5,700 and variable cost per unit of $6.50. We are required to compute the break-even point in units if the selling price is $8 per unit at all levels. Then you're also required to compute the break-even revenue. Then you're required to compute the CS ratio. Then to compute the margin of sales, if you are given budgeted sales as 5,000 units. So for A, we start with the break-even point formula, which we already met as fixed cost divided by unit contribution. Our fixed costs were given as 5,000. Unit contribution, which we compute by subtracting sales price minus variable costs, which gives us 1.50 to give us 3,800 as the unit required to be sold for us to break even. Next, the break-even revenue. So get the break-even units times the selling price. 3,800 times 8 will give us 30,400 as our break-even revenue. For the CS ratio, it's the contribution per unit, the contribution which we found in A as 1.5 divided by the selling price of 8 to give us a CS ratio of 0.1875. We could also use the other formula for break-even and CS ratio to get the break-even revenue, which is the fixed costs 5,700 divided by the CS ratio of 0.1875 to give us the break-even revenue of 30,400. The margin of safety, which is given by the budgeted sales of 5,000 minus the break-even sales, which we got as 3,800 to give us 1,200 as the margin of safety. To change that, to take that to a percentage, we divide by the budgeted sales of 5,000 times 100 to give us 24%. What does this mean? This means that sales volume must fall by 24% from budgeted level before a loss is made. Then finally, what is the sales volume in units required to make a profit of 10,000? So we use our output required for target profit formula, which is given by fixed costs. So fixed costs we know is 5,700. Our target profit that we want to make is 10,000. Our unit contribution is 1.5 to give us sales volume of 10,467 units as the sales volume required for us to make a profit of 10,000. That covers the formulas that we need for a single product. What are the limitations of break-even analysis? Break-even analysis is a useful technique for managers as it can provide the managers with simple and quick estimates. It is a form of sensitivity analysis and is therefore useful for assessing risk surrounding the estimate of sales volumes. However, it does have a number of limitations since it assumes that all costs can be split into fixed and variable costs. The second assumption is that the fixed costs are constant, the variable cost per unit is constant, the selling price as well is constant, and lastly, this inventory levels are constant, meaning whatever has been produced is sold, so your sales is equal to your production, which may not always be the case. We now move to break-even charts. The break-even point can also be determined graphically using a break-even chart. This diagrammatically shows the relationship between revenue, costs, and sales volume. In the previous exam structure, you were actually required to draw the diagrams. You would have been provided with graph paper and you had to draw some form of a chart and label the charts. But now, since the exam is computer based, the examiner will provide you with a chart and then you'll be required to label the charts. So be comfortable, understand the charts, how they are derived, understand the lines, the makeup of the lines, so that you are able to identify which line represents which point and be able to label the lines accordingly. So we have the break-even chart for the data in lecture example 1, which has been sketched for us. So we're required to match the following labels to the letters in the graph. The first line is the total cost line. Then we're required to label the margin of safety, the break-even point, and the total revenue lines. So this is a chart that we need to label. So A is our break-even point. We had computed 3.8 as the break-even revenue. So where the two lines intersect at 3,800 units, that's the break-even point. You've got the sales and costs on the y-axis. You've got your sales units on the x-axis. B is the margin of safety. We had computed the margin of safety as the difference between the budgeted sales of 5,000 and the break-even sales of 3,000. So this B area here is our margin of safety. C is our total revenue line. Total revenue will start from 0, because if you have sold nothing, you make nothing. As the sales increase, so will your revenues. And D is our total costs. So we have our fixed costs. Remember, fixed costs will always be there, even with zero production, even with zero sales. So the line which starts from the 5,700 will be your total cost line. So that is our D. Again, be able to label the lines if you are given in the exam. Proceed. We could also draw a contribution graph which shows that the gap between the total revenue line and the variable cost line is a contribution. So the total revenue line, which starts from 0, which is that one, and the variable cost line, remember variable costs will also start from 0, because at 0 production there will be no variable costs. So both the sales revenue line and the variable cost line will start from 0. So that's your sales line, that's your variable cost line. You've got your fixed costs there starting at 5,800. So this gap here gives us our contribution. This gap here between the sales revenue and the total cost gives us our profit. Another chart is the profit volume chart, which is an alternative to the break-even charts, as it illustrates the relationship between profits and sales. This one emphasizes the impact of changes in profit and volume. We'll continue with this chart in the next video.